Greetings, I'm Amar from Team Coton, and this is our submission, GrubGuru, for ArangoDB's hackathon. So in this video, we'll be going through a little bit of an introduction of our team, the background of why we're joining this hackathon, the problem statement that we're trying to solve, and a walkthrough and live demo of our Jupyter notebook. It's no secret that AI is growing in use across various fields and industries. As electrical and electronics students, we were motivated to embrace the challenge and take on this hackathon as a way of expanding our skills and knowledge beyond just our primary field. We hope the new insights we've gained from this competition will be able to enhance our future career prospects. So, what issue is our team trying to solve? Online shopping can be very overwhelming due to the endless product choices as well as the abundance of hundreds and thousands of reviews that add to the frustration and especially time needed to search for trustworthy products. For this reason, we've developed an intelligent agent called GrubGuru. GrubGuru utilizes the fine food dataset of products and reviews from Amazon and processes it to provide fast, clear recommendations based on user preferences and past consumer feedback. Now, we'll be moving on to the walkthrough of our notebook to better explain our submission. So before we are able to run anything in our notebook, we'll have to install all of our dependencies. I'll just briefly go through all of them, as well as import all of the required dependencies to run our notebook. So we convert the data frame that we've defined before to be our network X graph. So within the dataset of fine foods, we have products, users, and reviews. Users represent the start node, products are the end nodes, and reviews are the edges between them. We persist the graph in our database, we create the Arango graph LangChain wrapper, and then we authenticate with Mistral API since we're using models from Mistral AI.
For graph visualization, we just took advantage of the built-in graph visualizer in ArangoDB. So here we can just click on an edge and immediately find the edge attributes as well as the nodes that connect the edges.
So we've created a few tools that our agent can use in answering any query. The first tool allows the agent to convert any query to AQL, execute the query, and retrieve the result back in natural language. The second tool available for the agent is similar to the first, but instead of translating the query into AQL, it uses it to invoke a network X algorithm, which is then executed, and the result is translated back into natural language. The Plot Review Edge tool allows for a single edge of a network X plot to be drawn using nx.draw and matplotlib. This allows a single review from a user to be plotted and shown by the agent. The next tool is similar, except that it plots multiple reviews from a single user instead of just one review. We've also created a function that allows some of the previous tools to return a short description of the review. The last tool available lets the agent look at past queries and answers as a way of answering new queries if they have already been answered before. After defining all of the tools, we've then set up all its attributes, such as its name and description.
So this is our rate limiter section. We use this code to make sure that the tokens are not being generated at a rate that exceeds our current free plan, but your mileage may vary. This depends on the LLM that you're using. But for the free LLM that we're using, we require the rate limiter so that it doesn't throw a 429 HTTP error. Now this is the agent and the parser. So this is just the pre-built React agent from LangGraph, and this is our parser function that takes in the messages that's coming from the LLM API and parses them for our Gradio chatbot component. Finally, this is our file and chat history storing functions, which are used to handle saving current queries and loading up past queries. Finally, this is our app logic. This is our Gradio app. So these functions are all to handle the plots that were generated, as well as the chatbot message component, and pretty much all the buttons and interactions that we have. Finally, all you have to do is to run this cell to instantiate the app. Here the agent uses AQL to retrieve a random review, and it shows who wrote the review and what score that was given and the gist of the review text. Some queries can be run more efficiently with CUDA acceleration. For this example, network X algorithms are used. Here the agent is helping to visualize the information from a single edge, which is just a pair of start and end nodes. So this is one user and one review from that user. This is another use case where natural language being converted to AQL can be very convenient. Here we are requesting multiple information from different edges. So we have a lot of review attributes for each edge, and here we can see that the agent is effectively producing AQL code. In this example, the agent is using a tool that can help to visualize the results of a query. So for example, multiple edges might be returned. So in this case, we have multiple reviews, that is multiple edges that is connected from the same start node, which is the user. So this enables the end user to more intuitively visualize the results of the query.